Hello, Hojam. My name is Muhammet ASLAN. I'm from the Mechanical Engineering Department. This is my video assignment for MEX152. I took the course called Machine Learning Master Zero Mastery. I chose the fourth lecture. It's called Dimensionality Reduction. Let's continue with our presentation, my presentation outline. I will start with the curve of the dimensionality and continue the solution for this one. It's called a dimensional reduction. And third one is the importance of the feature scaling. The next one is the PCA, this time tag. Another one is the uses of dimensionality reduction, plus the references. Curve of dimensionality, let's continue with that. Curve means that this is our problem. Fundamentally, when we increase the features, that means that we can performance improve of the images performance. And you can see from the figure, in the one dimension, we have the 10 positions, two dimensions, X and Y, we have the 100 positions. And when we increase the dimension to 3, from the 2 to 3, this means X and Y and Z, this means 10,000 positions. But in the real life, having more features result in worse performance. And this is our problem. With the dimensionality, the quantity of training instances required grows exponentially. And let's give the solution for this problem. And as you know that when we get the data from the subsets, for example, here in the figure 1 and 2, there, figure 1, we have the two dimensionals, X and Y, it's called the height and squared days. But how can we make one dimensional? Because when we increase the dimensional number, it means that features performance is decreasing. The solution can be that we can combine with the transformations that are both linear and non-linear. In the figure 2, we reduce the dimension from the 2 to 1 with the linearity. And let's talking about the importance of this linearity and feature of scaling. In the figure 3, and the unscale is seen by the purple color, and the scalar is seen by the green one. And what are they doing for reducing the dimensionality? And they are capturing the most effective variation and data when you are doing the linearity. And also all data must be included here, but it's here X1 and X2 data are gathered here, but we don't know, and the performance of the feature can be reduced because of this one. But the importance of the feature scaling is giving us linearity of this data in the one line. And then let's continue with the analysis, principal component analysis, the time tag. And firstly, we create a class containing the order dimension of the reduction method. And then we create an instance of this class and PCA instance, call it PCA instance. And the y is meaning of the scale and the center of these data. And then we put the instance and let's fit this instance on the data and then transforming this data with the PCA instance fit transformation code. And how can we use the use of the dimensionality reduction? As you know that our phones are taking a photo with the high pixels, right? And this means that it is the more combinations and giving the more, taking the more data. But here, in the figure 4, the picture is divided 12 by 12 section. And the figure 5, and in this in this section, 12 by 12 section, we are creating row with the 144 feature, just only one. And then we are increasing the feature numbers until the 144 again. And this means each section has the 144, and then we have until these sections rows until the 144. You can see from the bottom. Yes, when we give the PCA dimensions into these images, the first one is that 144 dimensions, that its megapixel is really good. When we reduce from the 144 to 60, it makes a little bit bubble, and then in the figure 7 is reduced on 16, and the figure 8 is reduced on the 4, and the last figure 9 in the figure 9 is reduced on the 1. This means that the reduction methodology can be used here, and then with using the features, and you can see the results with the pixel and the quality of the picture. This is the graphical results. When we increase the PCA dimensions, the relative error also increases and closes the 1. This is my reference. Thank you for listening.